We're going to revisit greatest common factors with larger numbers. And because they're larger numbers, we actually have two different ways that we can work this greatest common factor. We're going to go back to the way that we found our common factors before. So the first thing I'm going to do is I'm going to start to make my factor list. I start with the smallest number. I like the easiest. And I know 1 and 152 are going to evenly divide into 152. Now, because 152 is an even number ending in 2, I can also cut that in half. So I know that 152 divided by 2 is 76, right? We can say 152 divided by 2 is 76. I'm going to keep incrementally working my way up this list. So I'm going to take 152 and divide it by 3. It doesn't divide evenly. I'm going to take 152 and divide it by 4, and I'm down to 4 multiplied by 38. I'm not sure if you can hear my calculator typing, but I'm not doing this in my head for all of the numbers. Some of them I'm using my calculator. I'm going to move up incrementally on my list to number 5, but I can obviously see that 5 is not going to divide evenly into 152 because it doesn't end in a 5 or a 0, so I'm going to try 6. I'm going to take 152 and I'm going to divide that by 6. It's not an even number, so I'm going to move on. I'm going to try 7. That's not an even number. I'm going to try 8, and I get 8 and 19. 8 multiplied by 19 also equals to 152. So I keep working my way up the list. I'm going to divide that by 9. Doesn't work. 10 doesn't. We already know that. So I can skip 10 because it doesn't end in a 0. I can try 11. That's not nice. I could try 12 and 13. And I'm not writing them down because they're not working. And when I say not working, it's because I'm getting these ugly decimal numbers. I tried 152 divided by 14. It doesn't work. I don't need to do 15, so I'll try 16. Oh, it was close, but not quite. Came out to 9.5. 152 divided by 17, I can try. 152 divided by 18. I feel like this is going on forever, but now luckily I'm done. And I know I'm done because I have already got 19 on the other hand of this list. So I know the factors of 152 are 1, 2, 4, 8, 19, 38, 76, and 152. So I'm going to try this with 190. Hopefully it'll go a little bit faster, but we'll see. We've got 1 and 190. I can see that it's even, so I'm going to take 190 and cut that in half, and I'm going to get 190 cut in half is going to equal to 90. Oops, that's not true. It's 95. Sorry, my bad. I'm going to try 3. 190 divided by 3 doesn't work out nice and evenly, so I'll try 4. 4 doesn't either, so I'm going to try 5. So if I have 190 divided by 5, I get 5 and 38. That's interesting. I'm going to try 6. I'm going to try 7. I'm going to try 8. I'm going to try 9. And I know 10 for sure, right? So I got 10 and 19. Now I can keep going up this list here. I can say 190 divided by 11 doesn't work. Divided by 12 doesn't work. We could try 190 divided by 13. And so we can see we've pretty much exhausted this list up until I get to 19. And just by practicing going through that nice systematic way of incremented up by 1, up by 1, up by 1 until I hit the other side. So now I can say the factors of 190 are 1, 2, 5, 10, 19, 38, 95, and 190. Our question asks for the greatest common factor, so I'm going to look for the largest number that exists in both lists. So our greatest common factor, or we call it a GCF, between 152 and 190 is 38. I took a long time. So what we're going to try and do is we're going to try and shorten this method by finding what our prime factors are. So we're going to start with 152. Now, we're kind of lucky. We just found a couple of our lists. So we could take any of those numbers that we had in our list. We had 19. I'm going to go with 19 because it's a prime. And I know 152 divided by 19 is 8. So 19 is a prime. I'm going to go with 8, and this is us working both sides of the tree at once. Here, 8, I've got 2 times 4. I know 2 is a prime, and I know 4 is 2 times 2. So I can see the prime factorization of 152 so far is 2 times 2 times 2 times 19. Now, we haven't talked about this, but you can actually double check that. In your calculator, times 2 times 2 times 2 times 19, and you should get the answer of 152, and that's an excellent way to double check your work. We'll do 190. I'm going to work both sides of the tree at once. I've got 10 and 19. I've got 19 is going to equal to a prime already, so I can stop there, and I get 2 and 5. So that was actually quite a nice, easy prime factorization. So I have 190 is actually equaling to 2 multiplied by 5. Whoopsie, sorry. And multiply that by 19. Double check that in your calculator. 2 times 5 times 19. I should get up to 190. Now, when we are trying to find the greatest common factor in between two numbers, what we're going to do is we're going to actually take all of the numbers or all of the primes that are in both lists. So I can see there is a single 2 in both lists. Now, I know there's another 2 here, but it doesn't have a partner in the other list. 5 doesn't have a partner either, but 19 does actually have a partner. So if there's a single 2 that is shared between those two lists and a 19 that are shared between these two lists, I can actually say 2 multiplied by 19, which happens to equal to 38, is actually going to be the greatest common factor between those two numbers. So to recap, to find the greatest common number between two larger numbers, we can find their prime factorizations and remove all the primes that are common, multiply those together, instead of actually finding every single factor to those two numbers. So we can again say the greatest common factor between 152 and 190 is 38. Same answer, two different ways.